Alright, this is an Algebra 1 lesson on properties of exponents. The objective, students will simplify expressions with zero and negative exponents and evaluate exponential expressions. So with exponents, you need to recall that x squared really means x times x. 2 to the fourth is really like saying 2 times 2 times 2 times 2, not 2 times 4, which is 8. 2 times 2 times 2 times 2 is actually 2 times 2 is 4, 2 times 2 is 8, 4 times 2, or 8 times 2 is 16. So this is really just 16. A to the first is just a. Okay, these are things that you should know before going into this lesson. Now, the first property I want to show you is 0 as an exponent. Whenever we have 0 as an exponent, anything to the 0 power is 1. Okay, you could have x, y, z, all of that quantity to the 0 power, it's 1. It doesn't matter if it's a bunch of letters. It could be also a big number like 13,537,000. All of this to the 0 power, and it's all equal to 1. So it doesn't really matter what you use. As long as it's to the 0 power, it's equal to 1. So that's an easy find. The other type of property I want to show you is a to the negative n power, which is when we have a negative exponent. In math, we don't really like negative exponents, so what we like to do is try to get rid of it. So we know that any term could be made a fraction by putting a 1 under it, such. So this negative n only applies to the term before it. The term stays the same, but we want to make the negative n actually be positive. So what we do is we move this all to the bottom, and we say this is a to the nth power, and we put 1 on the top. So basically you can make anything a positive exponent by flipping it to the opposite end of the fraction. So that's one example. Here's another example. Let's say we had x to the negative second power, and we don't like that. All you have to do is make it a fraction, and then move the x to the negative second power, keep the base of x, and then make negative 2 positive by putting it in the denominator, where 1 is left in the numerator. Another example, let's try to make it a little harder. We have x squared y to the negative second power. Okay, make this all a fraction. We don't like this negative here. This x squared is positive, so we don't have a negative exponent, so we don't want to move that. But y to the negative second power is negative, so we just want to focus on this right here. So what you do first is you make an equal sign and keep your fraction bar. The x squared is positive, so we want to keep it in the numerator. The y to the negative second power is not positive, so we want to move that to the denominator, so it's y to the second power. So we have x squared, y squared is our simplified answer. Okay, and also one last example before we move on to our real examples is, let's say we had 2 over a to the third, or a to the negative third. Now we have a negative 1 in the denominator. Same rules apply, except you're going to move it to the opposite end of the fraction. So a to the negative 3, we don't want a negative third, so we move it up here. So it would be 2 times a to the third over 1, or your final answer is just going to be 2a to the third. Okay? So let's look at some of these. Number 1, 4 to the negative third. It's just like us saying 1 over 4 to the third. Now we want to simplify this, so this is also equal to 1 over 4 times 4 times 4. 4 times 4 is 16, and then 16 times 4 is 64. So this is like saying 1 over 64 is your answer. That's it on number 1. Number 2, 3 to the negative fourth power. This is just like saying 1 over 3 to the fourth power. And we could simplify that, expand that, so it'd be 3 times 3 times 3 times 3. And when we multiply that, 3 times 3 is 9. 3 times 3 here is 9. 9 times 9 is 81, so we know that this will be 1 over 81, or 1/81. as the answer. Last one, 3. Negative 4 to the negative third power. Be careful with this one because you might want to make this negative sign in front of the 4 positive, but this is our base, is negative 4. The base does not change. The base does not change. So really this is equal to 1 over, keep the base of negative 4, and then change the exponent to be positive. So it's positive 3. 1 over negative 4 to the positive third power. And when you work this out, you get 1 over negative 4 times negative 4 times negative 4. Now, we did something similar to this on number 1 over here, right? Right over here, and you're going to think it's 1 over 64, but be careful. So we have to multiply this slowly. Negative 4 times negative 4 is positive 16, and all of that times negative 4 again is going to be negative 64. So that's going to be in our denominators, negative 64. Numerator is positive, denominator is negative, so you're going to multiply, or when you have a positive divided by a negative, your answer is going to be a negative 1 over 64. That's how you do examples 1 through 3. Example 4. Now these are easy. These all have powers of 0. So again, like I showed earlier, negative 3 to the 0 power, this is equal to 1. Right, equal to 1, or negative 1 and 2300ths to the 0 power is equal to 1. Again, 13,966,000 to the 0 power is equal to 1. It doesn't matter what it is, these are all equal to 1. So essentially these are all equal to each other. Continuing on. Example 2, we talked about simplifying exponential expressions. So for example, on number 1, we have 4yx to the negative third power. So we want to look at all of our exponents. So we know we have an x to negative 3. We have to deal with that. Now, when I look at the 4 and the y, these are actually separate terms that are being multiplied together to become one expression, or one big term. So 4 has its own exponent, believe it or not, and it's 4 to the first power, right? And y has its own exponent, so it's to the first power also. These are both positive, so we don't want to be messing with these. So basically, we need to keep the 4 and the y, or basically we need to start off by realizing that this could be made a fraction by putting it over 1. The 4 and the y could stay in the numerator, so it's 4y. The x, however, needs to be brought down to the denominator, and you get 4y over x to the third power. 2, we have a similar problem. We have 11 and m to the negative fifth power, so we know that there's a multiply sign here. We know that 11 has its own exponent, n has its own exponent, and m is to the negative fifth power. So we can make this all over 1. So this is like saying 11 n, these stay in the numerator, and m to the fifth goes to the denominator. Okay, number 3, we saw this one a few minutes ago. We have a to the negative 3. We want to bring that up to the top, so we're going to write this out as 2a to the third over 1. Anything divided by 1 is itself, so 2a to the third is your final answer here. Again, if I'm going too quickly, please pause, rewind, do what you need to do on this video. Spend time to copy what I have down. Next is... Next is evaluating an exponential expression. So this problem says evaluate 3m squared t to the negative second power for m is equal to 2 and t is equal to negative 3. So when it says to evaluate, it means solve or find the answer. So first thing you want to do is find the expression. So our expression is actually right here, and it's in the sentence. It's kind of hard to find. But it's a good thing to take it out and just put it on your paper. 3m squared t to the negative second power. Okay. Second thing you want to do is simplify it. So we know that 3 has a power of 1 above it, so that's positive. There's a 2 here, that's positive. But there's a negative 2 here in front of the t, so we want to fix that. So we're going to make this all over 1. So it's going to be 3m squared over t squared. Okay? So if that's the case, we need to substitute. For m, we're going to put 2, and for t, we're going to put negative 3. So I'm going to bring up the problem up here. So 3. We're substituting m with 2. So we open parentheses. Make sure you, whenever you substitute, you open parentheses. Put the amount you're substituting with on the inside, 2, and then put the exponent down. Squared. Over t. T is equal to -3, so it's going to be -3 squared. Okay? So we got 3 times 2 squared over -3 squared. So simplify, PEMDAS. Parentheses, no parentheses we could work with. There are exponents now. So we have 2 squared is equal to 4, so it's 3 times 4 in the numerator. In the denominator we have -3 squared, so it's going to be 9. Simplifying, multiplication, 3 times 4 is 12 over 9. Simplify that. We could simplify that. We know that 3 goes into 12 4 times, and it goes into 3 goes into 9 3 times, so this is like 4/3. This is an improper fraction, so we could simplify this, make it a mixed number as 1 and 1/3 is your final answer. So when you work these out, make sure you're looking for the actual expression and simplifying. This is the last example of the lesson now. Evaluate n to the -3rd, w to the 0 power for n is equal to -2 and w is equal to 5. Now again, start off. Find the expression n to the -3rd, w to the 0 power. Simplify this expression. We have a negative power here. Let's get rid of that. Let's make it so it's in the denominator. So we're going to leave w to the 0 in the numerator. And we know that w to the 0 is actually equal to 1. So I'm going to do a double step here. We're going to leave 1 in the numerator to represent w to the 0. Okay? And then n to the -3rd we're going to put in the denominator so that it's positive. So now our simplified expression is 1 over n to the 3rd. Now we can start substituting. So whenever we see a letter, we open parentheses. So we have 1 over n is -2. Open parentheses, and it's to the 3rd power. This is like saying 1 over -2 times -2 times -2. Multiply this out. -2 times -2 times -2 is going to be equal to -8. So it's 1 over -8. Now, like before, the 1 on top is positive, the denominator is negative. So positive divided by a negative is going to be a negative answer. So it's going to be -1 over 8. And this concludes the lesson on exponent properties. More to come on the next lesson.